Hello, my name is Joshua Wilhelm, and I am the leader of the controlled subteam for the fall 2016 semester. Today, I will show you how to work with the Vision Builder AI software, which programs our smart cameras at the test bed. First, here's how you open Vision Builder. On this screen, you can see the camera that is currently connected and its IP address. Double-clicking on the camera will open it, and then the software will connect to the camera via Ethernet and open what's called the configuration interface, which you can see here. On the top of the screen, there's a button to open an inspection which is currently stored on the camera, which you can see me doing here. Right now, the current inspection on the camera is called camera connection. Clicking OK will download the inspection from the target to the computer and open it. As you can see, it has appeared on the top right screen. Using File, Save As, we'll save the inspection to the camera. Using File, Save As Template, we'll open up a file browser and save the inspection file to the local computer. This is useful to have a backup outside of the camera's own hard drive. In this main portion of the screen, you've got your main window, and over to the right side is a smaller side window. Along the top of the screen, you have various icons which do various tasks. These icons run the inspection. You can run it once, run it in a loop, run it until failure, stop it while it's running, and highlight its execution in order to see a step-by-step run-through of the program, which is very useful for debugging. You can also pause the program. Using this button swaps your two screens. The large screen and the small screen will swap, as you can see here. And you can swap it back. Over on the right side, you have the various steps you can add to your inspection. All inspections start from the green Start icon and then move through a series of states, which are these yellow blobs. Each state is shown at the bottom and is made up of multiple steps which run in sequence from left to right. These arrows are called transitions and move between states. Each state has a default transition which you cannot edit, and it is the default path of the program. In addition, you can also create custom transitions as I'm showing here. For these transitions, you select a variable, which is a measurement, from the drop-down menu, and then set its condition, which should result in this transition occurring. I will now create a new inspection to demonstrate how to set up your first inspection. This is the beginning screen of a new inspection. It consists of simply a start and an end block with one state in between connected by default transitions. To create a new state, simply right-click, select Create New State, and type in a name for the state. Then click OK. You can move objects in the configuration interface around by clicking and dragging them, as you can see here. I will now add this state after the already given inspect state by repositioning the transitions as shown. To create a new transition, right-click on a state and select Create New Transition. Then simply connect the transition to another state. To delete a transition, simply select it and press the delete key. I will now demonstrate how to acquire an image. First, I select the acquire image state, and the acquire image state is now shown at the bottom. Then I start an acquire image step. A setup box for the acquire image step appears. We can set parameters like the exposure time and gain, and set trigger parameters here. Set lighting here, such as the internal lighting or an external lighting, which we actually do not have. Calibration, which we will do in a separate step. And here are some specifications. When we've finished setting up everything how we like it for the photograph, we will select the OK button. The camera then proceeds to run the step once and show us the result on the main screen here. It's a picture of the block, which is currently under the camera. The next step is to calibrate the image in order to convert from pixels to millimeters or some other real-world unit. To calibrate this image using a calibration data that we've already created, in this drop-down menu we simply have to select that calibration. On the other hand, if we needed to make a new calibration, we would need to hit the new calibration button and run a new calibration, which is a step-by-step process. When we're finished, we just click OK. Now that our image is calibrated, we're going to try to detect an edge of the part. We come here and select Find Straight Edge. We then have to select a region of interest for the camera to look for an edge in. Simply drag a rectangle around the edge of the part. Then there are some parameters here under Setting in which we can fine-tune to try to find the best edge. And there we have a pretty good edge as indicated by the red line. Once we are satisfied, we can go and hit the OK button. We'll then repeat this process for the other edge of the part. There you can see the red line tracing the edge fairly well. So we didn't have to do much fine-tuning, but we can improve it slightly. And then click the OK button. Next, we will try to find the distance between these two lines, thereby giving us the length dimension of the part. We will select the geometry step and make a new measurement by pressing the plus button. We then select our measurement by clicking on this icon and selecting X distance between lines at Y. We then need to select 4 points. Using this dialog box, we will simply scroll to the points 1 and 2, the endpoints of our first edge, and the endpoints of our second edge, and select them in sequence. We now need to select a Y value at which the geometry measurement will make its distance measurement. That value looks like it's too low, so we'll try a bit higher one. That looks better. There you can see the distance reading it's currently making. As you can see, it's in millimeters because our image has been calibrated, and so it can convert from pixels to millimeters. So, in this state, we have acquired an image, calibrated it, found two edges, and found the distance between the edges. I will now create a new state to send this data we just acquired to the PLC. I right-click, click Create New State, and gave it a name, Send Data. I then connect it after the Acquire Image state. To send data to the PLC, we use a step called Ethernet IP adapter. You can click on it as shown here. We have on the left tab here PLC output, and on the right tab PLC input. The PLC output would be data we read from the PLC, while the PLC input would be data we write to the PLC. This screen shows the data we can send from Vision Builder AI to the PLC. As you can see, the first 8 booleans are reserved by Vision Builder to send specific data to the PLC. However, we can click any of the other booleans and put a check mark next to them. We can then use the drop-down to select what we want to send to the PLC. For example, we can send the value of the inspection status. However, to send the data we measured in the previous state, we're going to have to do a little bit more work. We are going to make use of a LabVIEW component of Vision Builder called Calculator. You can find it as seen here. It includes a wizard to get set up with the calculator. First, we need to select our input measurements. So we will find step 5 of the state, and we want our calibrated distance measurement. We also will want our status. I made a mistake at this point by forgetting to set the output results. However, if you do forget to do this, you can simply click Edit Inputs and Outputs over on the right menu and select the results later. Here, I click Add New Output Result and give it a name. In this case, I'll name it Part Length. I need to ensure the type is set to numeric for the length. Then I add a new output result and name it Measure Status. I will need to set its type to Boolean. Then click OK, and the 2 blocks pop up which represent the outputs. The 2 blocks over on the left represent the inputs, and I've connected the measure status input to the step result. I now need to add wires to hook up the different parts of the calculator. These can be a little bit finicky at times. This will essentially transfer the data stored in my inputs to my outputs. The reason we need to use such a calculator is because only these outputs are recognized by Vision Builder to be sent as data through the Ethernet IP adapter. Now that I've finished everything up, I click OK. Since I need the data from the calculator for the Ethernet IP adapter, I need to move the calculator step before the Ethernet adapter step. I do this by cutting the Ethernet adapter and pasting it behind the calculator. I can now go back into the Ethernet adapter and select as bool 8 my measure status to be sent to the PLC, as seen here. Now I can go over to the real numbers and select real 0. Since real numbers are floating point numbers, I can send the part length as a real variable. I then click OK when I'm finished with the Ethernet adapter. This will now send the data to the PLC when this state runs. This is a situation where a custom transition might come in handy. I create a new condition off the send data state and wrap it back to the acquire image state. I edit the transition and give it a name. In this case, I'll call it failed measurement. I'll select the measure status from calculator 1. If this is false, I'll transition back to acquire image because this means that the measurement failed. I will now show how to construct a basic PLC trigger to start camera inspections. First, create an Ethernet IP adapter in the first state. Then, on the Read tab, select bool 0 to receive from the PLC. You can actually see that its current state is true. Now switch back to the state view and right-click Create New Transition. Connect it back to the same state. This essentially forms a loop which will keep executing this state while the transition condition is true. I name the transition Signal Not Received. I then am looking for the Boolean 0 I read out of the Ethernet IP adapter and select the state to false. This will cause the inspection to loop in that first state looking for the PLC trigger. While it's not received, it will go through the Signal Not Received transition and end up back in that same state over and over again. Once the signal is received, it will move through the default transition to the acquire image state. I saved this inspection on the camera, so it should still be available for you to take a look at. I named it Training Inspection, so it should be easy to locate. Here I'm opening Camera Connection, which is the current program the controls team is working on. It is a bit more complex than the training inspection I showed and consists of multiple states. However, with the knowledge you learned in this tutorial, you should be able to figure out this program and hopefully make more contributions to it and continually improve it. I have linked to other training materials, some of them developed by NI, in the description to this video and the README. These are useful for more advanced topics and will help you gain further knowledge in Vision Builder AI software. Also, feel free to contact me anytime at the email address listed here.